Good afternoon, dear colleagues. I'm glad to welcome all of you here today at the seminar entitled Minerals for the Energy Transition, Technologies, Availability, and International Trade. This is a joint seminar organized by the Research Laboratory for Science and Technology Studies. My name is Liliana Proskurikova. I'm head of the laboratory, and the Institute for the Economics of Natural Resources and Climate Change. Igor Makarov, our speaker today, is director of this institute. Our working language is English, but if you feel more comfortable asking something or commenting in Russian, that is also okay, I suppose, and we can help with the colleagues who are not familiar with Russian with understanding the essence of your comments. The topic we touch today, energy transition and critical minerals, is of utmost importance in the research and policy making agenda. The research transition is highly dependent on critical minerals, and they play key roles in accelerating the low carbon development. And they affect the viability and the availability of clean technologies. Many other minerals are also essential for industrialization that is currently occurring or is forecasted in many developing countries around the world. Existing trends in the trade of critical minerals is what we're going to discuss today. We will also touch upon the factors that influence the formation of these trends, including renewable energy consumption, changes in energy efficiency, and carbon dioxide emissions. Today we have two speakers. The first speaker will be Nurkan Kilinc-Ata, Associate Professor at Sultan Qaboos University in Oman. We will also have a second speaker and a discussant. A few words about Dr. Kilinc-Ata. She is Assistant Professor at the Department of Economics and Finance at Sultan Qaboos University in Oman. She is also working in energy, minerals, and environmental economics. Since 2021, she held various positions at HSC, and currently she holds the position of Senior Research Fellow at the Laboratory for Science and Technology Studies. Since 2024, she also holds the position of Research Fellow at the Economic Research Forum in Cairo, Egypt. Her current work focuses on increasing resource use for energy transition technologies, determining carbonization drivers and challenges, including public perceptions, and assessing how important policies are in determining market outcomes. She's published multiple peer-reviewed journal articles that advance the use of economic theories to address challenges faced by the clean energy transition and market efficiency. So, Dr. Kilinc-Ata, the floor is yours.
Okay, thank you so much. I will change. Okay, I will change this here. Okay. Thank you so much, Dr. Liliana, and also thank you so much for the Higher School of the Economics, the organizing of this timely seminars. And I am pleasure to be here with you and to talk about and also to discuss the role of the critical minerals in the driving the clean energy transition. Actually, for the yesterday I'm talking, I would like to specifically I focus on the energy environmental economics, but for the last 2-3 years, and also I am focused on the mineral economics as well, because of course for this mineral, specifically for the critical minerals, directly related with the renewable energy technologies, and also of course this is directly pushing for the clean energy transition. Actually, today my presentation and title is the role of the critical minerals in driving the clean energy transition. Yes, I would like to skip further this because yes, Liliana introduced me, and I am working with a Higher School of Economics from the 2021, and still we have a connect, and we are doing the good projects all together. And also for today, I would like to start my presentation to ask the one research question, and actually my research question is what do these electric car, EV cars, and also wind turbine, and also for the smartphone have in a common? Actually, of course, for this, I would like to start this question because during my presentation, we can understand, we can maybe find this question answer, and so why and what, and we commonly use of this, we commonly use of the smartphone, electric EV cars, wind turbine, and also for the solar panel. Actually, of course, before, after this research question, specifically, I would like to mention, okay, and yes, all countries would like to reach net zero carbon emission by 2050 or by 2060. Actually, of course, for the to reach of this carbon emission, we can see huge huge development, and also for the highly shift from the fossil fuels to the renewable energy and also electrification. And also, of course, for this shift, okay, from the fossil base and renewable, this is directly based on the mineral intensive. Actually, of course, for this clean energy technologies needs more critical minerals. Actually, of course, maybe I'm in here, I mentioned critical minerals, but specifically I'm talking about the some of the critical minerals, and I will mention what is this critical minerals. I will mention in the next slides. And so, of course, we need the critical minerals than fossil base of the products. Actually, of course, in here, there's one example for when we look at in this example. Yes, mostly at the present, many people would like to use for the EV cars. And for this EV cars, okay, EV cars needs the 6 times more mineral inputs than the conventional cars. Actually, of course, for when we compare of the conventional and EV cars, for the EV cars, we are using for the more mineral resources. Actually, of course, also for another example for the wind turbine, actually for the wind turbine, we need 9 times more minerals than gas-fired of the plant of the same of the capacity. Actually, of course, this data is from the International Energy Agency, and also, of course, we can see in here. And so, for okay, I am looking for the mineral economics. I am looking from the demand and supply perspectives, and for the past 5 years ago. And when we look at the mineral resources demand is the less, supply is the more. At the present, demand and supply, between the demand and supply for the critical minerals, maybe these differences is the less, but for the what will happen for the next 5 years or 10 years later. Actually, of course, for that time, and critical minerals demand more than the demand supply. Actually, of course, for that time, this that is the problem, because why? Demand and supply balance will be broken. Actually, also will be broken, and for this critical minerals are very important. And so specifically, what are the critical minerals? And for the US Geological Survey in 2025, they can specify of the 60 critical minerals. Not all, just only 60. For these minerals include the lithium, cobalt, aluminium, graphite, and rare earths, nickel, copper, and for the others. Why for these 60 critical minerals? Because mostly we are using these critical minerals for the energy, technology, and defense investment. Actually, of course, for every 3 years, for these resources updated from the US Geological Survey Institution, but at the present, and for these 60 critical minerals are very important. Also, they are very crucial for the green energy transition. Actually, of course, for the minerals are critical, not only for the clean energy sectors, and also for the, of course, for in this presentation, yes, I am mentioning for the clean energy transition, but specifically when we look at for the 60 critical minerals, many strategic industries. I give the example, for example, military, and also they are using for these critical minerals, not just only. Actually, of course, for the maybe next 5 or 10 years later, we will there is a supply risk. We will meet with the supply risk for the next 10 years. Actually, of course, we will define of the critical minerals equal for the economic importance. This is economic is very important, and plus supply risk. And because we have to consider for the critical minerals from these two perspectives. Also, of course, in here there is some of the example from these critical minerals, and for the lithium, cobalt, nickel, of course, just mostly we are using for this for the batteries, and of course some of the countries, batteries for the EV cars, and also some of the countries is the focus on the hydrogen energy. For example, Oman is the focus on the green hydrogen energy sources, and of course for the green hydrogen for the batteries is very important. Specifically, they have to use for the lithium, cobalt, and nickel, and rare earth elements. Actually, of course, this is the also important because for the this is the generally companies using for this materials as a magnet, and for the mostly we need this critical minerals for the wind turbine and also EV cars, copper, and also silicon and silver. Silicon mostly we need for the solar panel, and also for the copper. Actually, for the copper, generally we are using for the copper all kinds of the renewable energy technologies. Actually, of course, in here there is a more detail, but I don't wanna, specifically I don't wanna talk about this. But of course, in here we have some of the critical minerals. There is a main use area and other use area, and also, of course, for the another important issue in here for this critical minerals located which country or which region. And actually this is the very important when we look at the cobalt, and for the cobalt more than the 60% located in the Africa, Democratic Congo, Democratic Republic of the Congo, and in Russia, just only 5%. Actually, of course, and some of the region and also some of the countries has a control some of the critical minerals. Actually, this is the very important for the next 10 years. And also, yes, in here, sorry. Also, of course, there is some of the examples, and so we are using for these critical minerals in the transportation sectors. Actually, of course, for the transportation, for the first part of this graph, and compare with the EV cars and conventional cars, and for the second part of the graphs, compare with the power generation. Actually, of course, when we look at this power generation, there is renewable energy sources and also for the conventional energy sources, and of course we can see, and everything is so clear. And so for this critical minerals mostly use renewable energy technologies. Renewable energy. Of course, in here there is a more detail. For example, for the for the wind turbine, we are using for the copper, rare earth, and aluminium, and also other materials. And also for the solar PV, and we need the silicon, titanium, copper, and also for the other renewable critical mineral resources. Actually, of course, everything is it is clear that. And so for the wind, solar, and also EV, and also for the batteries, clean energy base of the batteries, we need these critical minerals. Actually, yes. for the till the now, and so just on I am talking about the what is the critical minerals, and so why this critical minerals driving of the clean energy transition. Actually, with this slides, and I will specifically I would like to mention for the demand and supply. And so, of course, clean energy demand is the increase over the years, and so for the future, demand is expected to increase significantly, and also of course this is the directly pressure on the supply channels. Actually, there is some of the statistic from the International Energy Agency, and they make the forecasting for the 2040, and for the 2040 they expect to increase of the lithium demand more than the 40 times, and graphite, cobalt, and nickel, they expect to increase of the 25 times, rare earths 7 times, copper, and also they expect doubles, and also of course for the maybe other related of the clean energy areas, we will use the more critical minerals. And also of course for this clean energy transition is the increasing over the time, because of course all countries would like to reach the zero carbon emission or a net carbon emission, and almost 198 countries signed for the Paris Agreement. Based on this Paris Agreement, they have to reach. Actually, of course, we expect to increase of the clean energy technologies. Actually, of course, for the critical minerals is very important, but we have to look at these sources from the geographical perspectives. And because of course there is a geographical fragmentation in the critical minerals, and this is the kind of the, maybe in here I wrote any great game, because also maybe we of course we watch for the news, and also for the Trump when we go any countries, and they can negotiate with the countries based on the critical minerals. And so for Ukraine, for example, yes, okay, at the present Ukraine, okay, Trump requests from them critical minerals. Why? Because of course he knows that for the next 10 years, and for the next 10 years, and so they would like to be strong in the world. And so, but at the present, when we compare for the countries, and most of the critical minerals under the control of the China. And so for the also specifically when we look at in this critical minerals as a region, and for the African regions, okay, they are very rich in the critical minerals, and but who can extract of the critical minerals from the Africa? China, and mostly China-based of the countries. And also, of course, they can extract of the critical minerals from that. They can processing from the China. Actually, of course, and for the futures, for the 10 years later, and so for this demand and supply market in the critical minerals under the control of China. Actually, of course, in here there is some of the example, and also, of course, yes, this is the very important, but there is a risky situation in here. For this risky situation, geopolitical tensions, and for the trade of the policies, actually, of course, this is the directly disrupt of the entire of the global transition. Yeah, for the last year, Trump set off some of the regulation for the China, and a couple of the weeks later, a couple of months later, he removed all of them. Because why? Because China China responds the same way. Actually, China set off some of the regulation. Actually, of course, for the futures, okay, and so they this is the they would who is the strong of the critical minerals? Of course, they can maybe they can yeah, they have the control of the market. They have the control of the market. Actually, Yeah, in here, okay, there is a more extraction. Actually, of course, this critical mineral resources is the extract from the different countries. But specifically, when we look at in here, processing, this is important. And so for the trading, after the processing, they can make the trade. And so, okay, mostly China is the, we can see for the China. And so, but also in here, there is a sum of the data. And for the 70% of the cobalt distributed in the Democratic Republic of the Congo, and 20% actually for the Russia, of course, maybe nickel. This is your important mineral resources for the Russia. For the just only 20%, and for the China, 60% of the rare earths. But just only this is a small example, but in a general, and most of the critical minerals under the control of the China. Actually, for the last part of my presentation, just I would like to talk about my papers, and I have the maybe more than the 5 papers related with the critical minerals, but just one I would like to mention for the last 2 paper. And the first paper is the this one. I think so, not this one. Okay, okay, sorry. I would like to pass this presentation. This is the I give the lectures. Okay, this here. In here, there is a in this presentation, I talk about some of the challenge and sustainability challenge, and for this challenge related with the environment, related with the social license, carbon footprint, and circular economy, and also, of course, for this all challenges related to each others. Okay, just one. And also, of course, for this challenge, what can we do? And for this challenge, we can follow some of the policies, and for this policies related with the diversification of the supply, and innovation, recycle, and strange of the ESG standards, and for the maybe strategic alliances, they are very important, because also in Oman at the present they would like to reach off the zero carbon emission 2050, and also Oman is the dependent country on the oil, Oman economy, but of course at the present they would like the diversification of the economic diversification of the economy, because of course for the 10 or for the futures, and so they need this one. And also, of course, at the present they have different, they can diversify of the supplier, not just only they are working in the Europe, and also they have some of the partners from the Asia, and also Europe, and also GCC as well. And also yes, in here there is a yes, here. Yes, in here, last part of my papers, actually, please ignore of the another one of my slides, and actually this is the related to my paper, but I have to remove that one. Actually, this is my last 2 papers, 2025, they published, and the first one is the critical minerals dilemma, and rethinking the energy transition strategy in the Africa. Actually, of course, in here, this paper is published in the Resources Policies Journal. In this paper, I apply for the econometric analysis, and for the econometric analysis, I use for the cross-sectional autoregressive distributed model, and so I selected 21 countries. Why I selected 21 countries? For these 21 countries, and they are the rich some of the critical minerals, and so for this paper specifically, we look at for the 2023, and when we look at for the in here, I chose these countries, some of the countries in here, and specifically cobalt, 67% producer is the Democratic Republic Congo. Chrome 90% produced from South Africa, and platinum, and for the others 80% is produced from the South Africa and Zimbabwe, and also graphite 20%, and also lithium, and also Zimbabwe and Democratic Republic of the Congo produce of the, but it is okay, produce of these resources. But in here, yes, they are the main producer, but as a country, we can, they are the main producer, but all companies based on the China, not Africa. Okay, what is my key findings in this paper? Actually, of course, also for this paper, I am not diverse classified of the resource critical minerals, because unfortunately it is very difficult to find of the data for the African countries. And so, in a general, we will get the import and export data for this selected African countries. Actually, of course, for the total mineral imports, okay, not shows a positive response expansion of the renewable energy capacities in the African countries. Actually, maybe we are not expect to see for this result, but for the African countries, okay, this is the logical. Why? Because of course they are the main producer, but unfortunately they are not using for this critical minerals to improve for the renewable energy sources inside of the countries. Because of course these critical minerals produced from that countries, but processing process in US or in China. And so of course for the other developed countries and using of the African mineral resources. And also, of course, also for this outcome, these results suggest renewable energy production is not extensively utilized in the African countries. Yes, okay, maybe they are the largest importers of the minerals, but for these mineral resources using from the other developed countries. My second paper's title is the role of the mineral raw materials imports in the driving energy transition. Actually, of course, in this paper, address a specific gap in the mineral energy nexus. Actually, in this paper, we are not looking for the mining or final technology trade, just only for the important steps, the import of the raw materials, ores and concentrates. Actually, of course, for this raw material ores of the concentrates, specifically we chose the 5 minerals, and for the copper, cobalt, aluminum, nickel, and magnesium. And for this paper analyzed based on the OECD and non-OECD countries, OECD and non-OECD countries. And so we have the 33 countries, and based on these countries, and we set off the 5 hypotheses. The first hypothesis is the import of the mineral ores and concentrates. The second one is the comprehensive environmental policies. The third one, energy efficiency and measure, energy independence and consumer demand and income. Actually, of course, for the import, okay, the import of the critical minerals is important, and also for this critical minerals, how impact on the environment, to see for this, and we will get the data from the environmental perspectives. And in here also end of the we run the analysis. After the analysis, we or analyze state that just only hypothesis 1 and 2 is the working, for the other hypothesis is not working, and all one of the or control variables is the EPS. This is the environmental price stringency. It means that in here this is the we can say that for the environmental base of the policies working for clean energy transition based on the critical minerals. And also for my another findings in this paper, this paper, yes, here, no, sorry. Another, of course, this is the MOC, directly reflects of the 5 minerals. This 5 minerals imports and also stringency of the policies directly determining the pace of the renewable energy transition. Actually, of course, I would like to conclude my presentation, and specifically, I would like to mention no energy transition without the mineral without the critical minerals. Actually, these critical minerals are essential. They are. This is the essential for the futures, and also, of course, for the strategic, systematic challenge, combining of the geopolitics, technology, economics, and sustainability, and also, of course, how we manage this challenge will determining of the speed, cost, and also equity of the clean energy future. Actually, of course, end of my presentation, we can say that, and so at the present, commonly we are using for the smartphone, EV cars, and also wind turbine, and also yes, we are for this products we need the critical minerals, because for these products and also for these new technologies based on the critical minerals. Thank you so much for your attention. Yes.
Thank you so much, Dr. Klinkata. For those of you who are connected online, I would like to invite you to put comments and questions in the chat. We will also address yours. For those of you who are present here in the room, please also prepare the comments and questions, which we can take in the end of the seminar after the second presentation and the comments of the discussant. Our second presenter is Igor Makarov, head of the School of World Economy and of the HSE University. He is also the director of the Institute for Economics of Natural Resources and Climate Change. Igor is editor-in-chief of the journal Comprehensive World Economy. His research interests cover climate change economics and international political economy. He is one of the leading authors in the World Bank report, Russia and Global Green Transition, Risks and Opportunities. Also a contributing author of the 6th assessment report of IPCC, and an author of more than 60 academic papers and numerous columns in Russian business newspapers. Igor, the floor is yours.
Okay, thank you, Liana. Thanks for this kind introduction, and thanks for the initiative to organize this seminar on this a very important topic. And my institute joined this initiative with a great pleasure. And it will be easier for me to present after Nurkan, because she made very comprehensive, general portrait of this very comprehensive topic, which touches upon different aspects, not only in economics and international economics, but also in geopolitics, in engineering a little bit, in the comprehensive area of green transition as such, and so on. So may I take a clicker, please? So my presentation will combine the two genres. The first is like academic presentation, so I will present some results of our academic paper, which is still in process, but it is already been submitted to the journal. It is co-authored by me, Bashir Wahab, and Igor Muravyov, who is here. But at the same time, I will share some of my thoughts and some of the insights, probably, of a number of dialogues, high-level dialogues, which were held on this topic in Cape Town, in Dubai, in Johannesburg for the last couple of years, where I participated, and where I also taught a lot about, I studied a lot from my colleagues and from different countries on these comprehensive issues, and I think that in my presentation will try to show how comprehensive really it is and how contradictory at the same time. So my presentation will be focused on four major thesis statements. First is probably the easiest one, that critical metals and minerals are necessary for green energy transition. I will illustrate it a little bit more, though Nurkan already did it brilliantly. Secondly, I will share some thoughts about unequal distribution of critical metals and minerals, which creates some new strategic interdependencies. To some extent, these interdependencies are similar to oil and gas interdependencies and the geopolitics surrounding fossil fuels, which was dominant for the last like 60 years, or even more. And when the green transition started, many people thought that it would be the end of geopolitics of natural resources because now energy is decentralized. Now electricity may be produced everywhere based on the domestic resources, based on some common resources like sun or wind. But not, it's not correct, of course, and geopolitics of green transition is not less comprehensive and not less contradictory than geopolitics of conventional fossil fuels. The third thesis is that the interests of importers and exporters of critical metals and minerals are different, and sometimes are even opposite. And in this context, I will raise two questions: how critical are critical metals and minerals, and how green are critical metals and minerals? And I discuss some narratives about these two questions. And finally, I will share some ideas and some reflections on the new strategic policies in producers of critical metals and minerals, which are developing in emerging economies and in developing countries for the last several years. So, critical metals and minerals are necessary for green energy transition. So in our paper, what we did not only like renewables or some other critical green technologies, but we took the list of environmental goods and the list of low carbon technologies and checked the hypothesis that in order to be competitive in producing these technologies, one should have access to critical metals and minerals. What does it mean in order to be competitive? It means that these countries which are competitive in producing these technologies, they are the exporters. So the research question is, do imports of critical metals and minerals matter for exports of environmental goods and low carbon technologies? So there is a wide discussion on this issue and on related issues in literature, and you may see that there are a lot of different reports and forecasts on the demand for critical metals and minerals and forecasts of trade in critical metals and minerals. And this discussion is led by International Energy Agency, of course, and every year International Energy Agency publishes reports or sometimes even a number of reports on critical metals and minerals. There is also a widespread literature on geopolitics of critical metals and minerals, all the issues related to the list of critical metals and minerals, the criteria of criticality, the risks of supply chain disruptions, the new dependencies which appear from China, for example, in the context of Western Europe or in the context of the United States. They are very afraid to be very much dependent on China in this issue, but not only on China, of course. Yeah, there is also a large literature related to the linkage between energy transition and critical metals and minerals, which focus mostly on renewables, not only on renewables, but still. So our contribution is twofold. So first is that we try to understand whether imports of critical metals and minerals may positively influence exports of green technologies and low carbon environmental goods and low carbon technologies. And we expand the analysis from renewables only to the whole set of environmental goods and LCT products. So we took 34 countries, mostly OECD, but some non-OECD countries as well. Altogether, they cover about 85% of exports of environmental goods and low-carbon technologies. We took the period from 2017 to 2023. So we took 2 lists of goods to make sure that our analysis is robust. So we made the goods as a list of environmental goods, which is prepared by OECD, and a list of low carbon technology products, which is prepared by the IMF. So from this list, we took, we also took the list of 22 most traded critical metals and minerals, which are shown here on the right-hand picture. So we checked whether there is a relation between trade flows in critical metals and minerals and trade flows of environmental goods and low carbon technologies. In terms of some key trends, you may see in the table that the world exports of both environmental goods and low carbon technologies increased dramatically for this period of time. And at the same time, in the figure, you may see that these 22 most traded critical metals and minerals, they are very different in terms of both values and volumes of trade. So this segment, critical metals and minerals, it is very much diverse actually, and it should be taken into account, and we take it into account in this paper a little bit later. So just to remind partly what Nurkan already said, that critical metals and minerals are necessary to produce a lot of green technologies. Here in this picture, you may see it for 8 major critical metals and minerals, 8 most traded critical metals and minerals, which we also will take separately in the next slide. So we made some econometric analysis, and in this econometric analysis, the main variable, so the dependent variable is exports of environmental goods or exports of low carbon technology products. The major independent variable is the imports of critical metals and minerals. We also took a lot of control variables, and we used the panel data with panel regression analysis with instrumental variables with country and year fixed effects, and took CMM imports in lags. So here are some results. So the most important line here is the first line, which shows that imports of critical metals and minerals is significant for exports of both environmental goods and low carbon technologies in all the models, for full sample, for OECD, for environmental goods list, for low carbon technology lists. And actually the results are very similar across different specifications. So in general, the increase of imports of critical metals and minerals by 10% leads to the increase of environmental goods by about 3 or 4%. And the same is low carbon technologies. Or we may take the same story by the opposite. So the rise of exports of environmental goods and low carbon technologies by 3-4% requires a rise of imports from critical metals and minerals by about 10%. So we may suggest that these results are maybe explained by some particular critical metals and minerals. For example, here, a bit earlier. Here on this figure, you may see that, for example, the volume of aluminium is the most important in the general volume of trade in critical metals and minerals, and in terms of values, copper is dominating. So probably the results are explained only by copper or only by aluminium, and everything else does not matter at all. So that's why we should make additional sensitivity analysis and to estimate the same regressions for specific CMMs, for specific critical metals and minerals, one by one. So we took 8 most traded critical metals and minerals and shown that for all of these critical metals and minerals, regardless of specification, regardless of whether we take environmental goods or low carbon technologies, for all of them, there is a significant relationship between exports of low carbon technologies and environmental goods and imports of these critical metals and minerals. Again, one by one, not for the whole group. When we submitted this paper to the journal for the first time, there were a lot of reviewers claim that you should make additional sensitivity analysis, you should make additional robust analysis. So we made about a dozen of additional robustness and sensitivity analysis, making using different types of models, using different types of specifications when we control scale in different ways, when we control like the level of development of countries in different ways. So I won't cover here the technical issues, but we made a lot of additional sensitivity analysis, and regardless of specification variables we take, everywhere the core result is the same. So the core result is robust across all specifications, samples, estimation methods, and so on. So the exports of environmental goods and low carbon technologies requires massive imports of critical metals and minerals. So this brings us to the second part of my presentation, my second thesis, that unequal distribution of critical metals and minerals is crucial here. So these trade relations, they actually appear because of this unequal distribution, because the major producers and exporters of low carbon technologies or environmental goods, they do not have their own production or their own processing of critical metals and minerals, with the only exception of China. China's exception is important, but it is only one country and one exception. So you may see on this picture the distribution of production of critical metals and minerals. So countries which are shown red are the among like 5% of production of any particular critical metals and minerals, and they are among leaders for many critical metals and minerals. For example, China has 5% or more of global production for more than 10 critical metals and minerals, and it is the only country like that. Russia is a country which is in 5% of global production for more than 6 critical metals and minerals, mostly palladium, platinum, gold, nickel, of course. Yeah, so you may see that only small number of countries actually producing a lot of critical metals and minerals. Even less equal situation is for processing, which is even more important, because yes, cobalt is produced in Democratic Republic of Congo, but actually cobalt is processed primarily in China anyway. And here China is absolutely dominant. Russia is the second country if we take the whole list of critical metals and minerals. And except for them, only all the other countries are far behind them. Canada probably also requires some mentioning, some separate mentioning. So of course, if we have such an unequal distribution of production on the one hand, and especially processing, which is crucial, actually, then we have massive trade flows of critical metals and minerals, and then we have such additional dependency, which we all now discuss. And special role here belongs to China. Nurkan already shown the more or less similar picture, but you may also see the picture on this slide, that China is absolutely dominant in providing to the global markets most of crucial critical metals and minerals, with a share achieving more than 90% for some of them, and more than 40% for most of them, actually. That's why China is absolutely central player in this market, of course. Then there are absolutely different interests of exporters and importers here. And here I want to raise two questions. The first one is, what is critical? So when we say critical metals and minerals, we usually refer to some lists of critical metals and minerals. For example, Nurkan shows a list of US Geological Survey. There are also lists of critical metals and minerals of the European Union. There are also lists of critical metals and minerals of some other countries. So there are more than 30 such lists actually in the world. They are all different. So of course, some of the metals are everywhere, but mostly these lists are very different. And a mineral is considered critical when it is economically important and it is difficult to substitute. And when it is difficult to substitute, then the risks of disruption of value chains, of supply chains is the most important. Yeah, and the question here is, to whom this list is critical? Actually, it is critical primarily for developed countries because for them, critical minerals are important for some strategic industries. It is the green technologies, but it is also electronics. It is also some arm technologies and so on. Very often, critical metals and minerals are considered like a synonym of green critical metals and minerals. Critical metals and minerals are those which are necessary for green transition. But it is not true. It is not fully true. In many cases, it is more or less similar, but there are many inconsistencies here. For example, in the European Union critical metals and mineral list, there is not only lithium, cobalt, but there is also beryllium, which is not used for green transition, but it is used for missile guidance systems. It is tantalum, which are used in electronics and capacitors. And there is also even coke and coal, which is not only not for green transition, but it is completely opposite for green transition, actually. And yes, Trump's race for rare earth elements, which he tries to find everywhere from Greenland to Ukraine and Congo. It is also not because Trump is a great fan of green transition, and for US, these rare earth elements are necessary for like solar cells or wind turbines, not of course for them. Yes, at the same time, we should understand that for most of producers of critical metals and minerals, these metals themselves are not critical. Absolutely, other minerals are critical for them. Fertilizers for agriculture are critical for Africa. Cement for construction is critical for Africa. Salt for food conservation, chloride for water purification. So minerals like that, not lithium and cobalt. So at the same time, we have a narrative that these metals and minerals are critical for everyone, which is not fully correct, actually. At the same time, we should also understand that critical metals and minerals are not green. So they are green only in terms of that they are used for producing of green goods. That's true. But at the same time, these are very dirty industries themselves. And mining of critical metals and minerals is associated with huge environmental impact. And this is one of the major reasons why there is nearly no such mining in the US. There is nearly no such mining in the European Union, though there are some deposits there. They are not as numerous as in South America or in Africa, but there are still a lot of deposits of critical metals and minerals in US and in Germany and in other parts of Europe and so on. So what we have now is some new type of pollution heaven. Pollution heaven, I remind you, it was the phenomenon when the developed countries, they moved some dirty industries to the developing world, especially in the 1990s. This term was very popular, and then in the 2000s, the idea was that yes, there are some heavens, there are some locations where pollution is okay, while in the developed countries, pollution is not okay. Now we have the same. But in this context of critical metals and minerals, this is even more cynical because the outsourcing of pollution now appears for producing of green goods. So, and these green goods are considered green, though they are not green at all. And so, of course, we need to shift in metrics of environmental footprints from territorial footprints to tracking environmental footprint along the whole value chain. And only after tracking this environmental footprint, we may actually say that these goods are really green. And my final slide is that this difference between interests of producers and consumers, of exporters and exporters and importers of CMMs, it leads to many political implications. In general, importers are interested in the rise of imports of critical metals and minerals, the rise of supply, and low prices, of course. Exporters are interested in more value added staying within their countries. And before last years, the narratives and the political efforts and the results of these efforts from importers were stronger, actually. But for the last year, the situation started to change, and many producers of critical metals and minerals, they started to use some strategic policies to maximize the value chain, the value added staying within their countries. Many countries started to consider critical metals and minerals not as commercial goods, but also as strategic assets. And of course, for them, the major example and the major template is China. In China, as early as in 1992, Deng Xiaoping said that Middle East is rich with oil, while China is rich with rare earth metals, rare earth elements. And for China, rare earth elements are the same as oil for the Middle East. It was in 1992. And this leadership of China in their production and processing of critical metals and minerals, it did not start from nowhere. It started from the 1990s when, for the first time, critical metals and minerals started to be considered as strategic industries. Then it is important to link critical metals and minerals production with the domestic market and local demand. To some extent, it relates to what Nurkan illustrated in some of her papers, that yes, critical metals and minerals are produced in Africa, but they are not consumed in Africa. Why? Because there is no demand for these critical metals and minerals in Africa. And it is not only the African case, it is to the large extent the Russian case, because we also have a lot of critical metals and minerals, except old, like Soviet time deposits, which were started to be developed in the Soviet Union. So we have a lot of rare earth elements, we have a lot of lithium, but they are not developed because there is no linkage with domestic demand. And for exporting them, Russian companies won't be competitive with China, compared with China. The same story is in Brazil, for example, where they also have a lot of deposits, but very, very small production, and so on and so forth. But in order to create the domestic demand, the industrial policies are needed in complementary industries. And these industrial policies also started to be implemented in many countries, starting from like local content requirements in production of green goods and finishing with even bans on exports of raw materials, like in Indonesia, which banned the exports of raw nickel and created very strong production of nickel within their borders, oriented to exports to China and to electric vehicles, to Chinese electric vehicles, to batteries for Chinese electric vehicles. Reframing resource extracting agreements, and many countries try to link them with the development of infrastructure, localization of technologies, and some of the statements, some of the aspects of this like deals are introduced in trade agreements between, for example, the European Union and Mercosur, which is still in process right now with the European Union and some African countries and so on. And of course, last but not least, partnership between exporters. So the importing countries don't like these ideas at all. They says that it is cartel. Cartel is very bad, but it is very bad for importers. For exporters, it is not bad. OPEC is not bad for countries which are a part of OPEC, right? It is bad for everybody else. So the same story may be created here, and some negotiations on this between African countries, for example, are already being started, but of course it is only in the start of the way. But I think that this strategic policies, they will continue with the rise of demand for critical metals and minerals in the future. So I will finish here. Thanks for your attention.
Thank you very much, Igor. The two presenters raised a number of interesting questions that we are going to debate now, and our debate will focus around some of the following issues, such as what are the critical minerals, what minerals are essential for energy transition, and what are the consequences of the uneven distribution of these minerals. What are the supply risks, and what are mineral requirements by the renewable and other energy technologies, along with the other industries? In what way the research results may be applicable to companies and for evidence-based science, technology, and innovation policies, the national policies of the countries that are importers and exporters of these minerals. To boost and kickstart the discussion, we are very happy to have with us Irina Gaida. Irina is the head of the Center for Digital Technologies for Natural and Climate Projects of the Carbon Polygon Program, Faculty of Geography and Geoinformational Technology of HSE University. She holds an MBA from Harvard Business School, and she is an experienced professional with a diverse background in management and consulting. Previously, she worked as a director of Energy Center at the Moscow School of Management Skolkovo, deputy director of the Center for Energy Transfer and ESG of Skolkovo Institute of Science and Technology. Irina's extensive career also includes roles at Novatech, Rockwell Capital, Boston Consulting Group, along with foundational positions at United Technologies Corporation, PricewaterhouseCoopers, and Softum. Irina, please, the floor is yours.
Thank you very much for the invite and for a very generous introduction. I'd like to build up on my prior experience, which was heavily focused around energy industry and in particular oil and gas companies, to kickstart the discussion of some of the topics presented by colleagues. I think, you know, I will name the energy transition minerals to leave aside the debate of what's critical and not and what's not, but let's talk about the minerals that are needed for successful energy transition. And I would argue that they are quite different from oil and gas in many sense. What makes them similar is that indeed there is geological uncertainty, like with oil and gas, and there is also high level of market concentration of reserves, or at least most lucrative reserves. However, there are two other sources of uncertainty which are actually quite different there. One is related with technology. It's technology of end use. And we are talking here about ever fast changing technology of electric vehicles, batteries, for example. The chemistry of them is making advances every year, and the composition and therefore demand for the energy transition minerals will be evolving fast. There is also an evolution of production technology, because unlike oil and gas, it's not so much that they are rare, it's more the fact that it's actually quite hard to produce. You can find them quite abundantly, but extracting them from low concentration deposits in a cost-effective manner is a challenge, and it's a technological challenge. We see a new processes emerging as we speak. And then, of course, there is a third component of technology, which is recycling technology. Unlike oil and gas, where you basically burn it once and it's gone, we are still using the copper in the economy that has been produced 200 years ago, because we can recycle it. And we are still using some other components. But indeed, if we look at the totality of energy transition, we are recycling less than 1%. And if we increase that to, well, ambitious targets are 50%, but okay, maybe even 20, we don't need to bother neither with trade nor with socially and environmentally challenging mining. So we can get what we need from the waste, the electronic waste we produce. And then, of course, the third source of uncertainty, which is quite different, although, of course, it exists, as we all observe, in the world of oil and gas as well, is geopolitics. And here we talk about which application, because indeed it's energy transition minerals, but absolutely the same minerals are needed for defense and aerospace and for fast-growing area of robotics and drones and you name it, and actually artificial intelligence computational capacity. And I wonder if repeating the same correlation exercise that Igor brilliantly presented and looking for correlations with those two applications will show higher dependence in more recent years. And secondly, of course, also linked to the question of the geopolitical uncertainty is a question of what the supply chain will look like for those elements. It's a question of security of supply. It's a question of environmental footprint of supply. Some users are more tolerant to high environmental footprint. Other users are more demanding, and also it's a question of economics as usual. So if we look at all of those uncertainties, it's actually quite different dynamics from oil and gas, and I would argue that in today's world, given those uncertainties, one no-regret move that the industry should be making is a heavy focus on recycling, because it cuts off a number of sources of uncertainty, and it makes it also less environmentally damaging. It requires significantly less water. It requires, like in some cases, up to 80% less water. It requires significantly less energy, which is one of the reasons why it's difficult to process energy transition minerals in the areas where we mine them. You need a lot of energy to do the processing effectively. So in recycling, you need 5 to 10 times less energy. And then the question becomes, as we also see in the paper from Igor, that we don't see that segment developing today. And the question to me is why? What are the barriers and why we can't effectively build it up when we look at producers who, okay, may be interested to develop experts, but can't necessarily do it on their own. And we look at importers who are in today high uncertainty environment, interested in secure and reliable supply chains. And of course, as I mentioned before, it's technologically challenging. You have complex products which were not built to recycle, so you have a lot of trouble separating lithium from the rest or gold from the rest. It's also sometimes relatively low concentration when you look at total waste in kilograms and look at the percentage of target mineral. It's hard to extract, and you need to choose what you extract. You can't extract all of it. It's also a high upfront investment. So for Russia, it's certainly in today's environment of high interest rates, a complex decision to make. And of course, it's also a lack of coordination along the value chain of the electronic waste or any waste of that type. And so to me, I think one important dimension of policy development in the importing countries would be increase the requirement to recycle along the value chain and increase coordination amongst the different elements of the value chain, from end users to producers to designers to the suppliers of the components and suppliers of materials for components. And then, of course, for the exporting countries, as Igor rightly mentioned, the lessons from oil and gas, particularly from cases like Norway, should be taken. This country has built national wealth on the basis of discovering that oil is required by someone just 100 years ago. And from that, they became the most competitive oilfield service player in the world, particularly in the offshore production. Well, if that's, I think if that ambition is put as a priority by the holders of the deposits of energy transition mineral, this competition can be won. Okay, I guess that's my questions.
Thank you very much, Irina. Now we can take a few questions or comments. As I mentioned, if somebody feels more comfortable with giving comments in Russian, that is also okay.
Thank you. It was very good presentation, and the first one, and the discussion. My question is, are there any assessments for the European countries to explore their own production of mineral, the critical metals and minerals? Yeah, about the possibility, to start produce their own lithium, because lithium is available in many areas, not only in China, but also in Europe as well. But it's just a question of dirty production that which is the real constraint for the production in the European countries. And I wonder, are there I wonder if there are some assessments of the volumes that can be turn up if technologically the production of rare earths and critical metals become available in European countries.
Okay, thank you very much. We can collect several questions, comments, and then we have a reaction from our speakers. So please, other questions, comments? Okay.
Hello, everyone. My name is Igor Muravyov. I work at the Laboratory for Climate Change Economics. Thank you for both presentations and comments after the discussion. My question, not about production and reserves, like to expand this idea about processing, because processing is more manageable to move across countries, so it's not like natural reserves, but still, of course, those are carbon and energy intensive, and also it could be explained by the pollution heaven hypothesis. But could it be like not only for critical metals and minerals, but also like a larger trend of deindustrialization, carbon leakage, etc., from the developed countries? So that's my question. So, for example, to what extent those problems with processing of critical metals and minerals is related to other heavy industries?
Thank you. Other questions, please?
Hello, everyone. My name is Marina. I work for both HEC University and Bank of Russia. Now I'd like to discuss a little bit of China. We know that China has a lot of resources of critical metals and metals, and it also is a leader of green technologies. But can we say that China is totally independent from the rest of the world in terms of critical minerals? Or maybe it does it have capacities to produce and to process the large reserves into the form which is usable for producing of green technologies. Is it enough? Or maybe China has to import some of minerals from the rest of the world? Thank you.
Thank you very much, Maria.
Hello, everyone. My name is Maria. Thank you so much for the speakers. I want to ask, I'm a PhD student. I'm focusing around this area, energy transition. I have several questions, and it comes to my mind. First, from the slide from Dr. Nurjan, no energy transition without a mineral transition. My bachelor degree is in geological engineering, and I know exactly how my professor there said for 50 years ago, they said fossil fuels will somehow end at some time. But until today, fossil fuels still used. And I'm from Indonesia, and we use a lot of fossil fuels, coals, and oil and gas. And it came to my mind why we need an energy transition. We need energy transition because climate change, the carbon footprint, lower because the technology. But according to geological time, why the dinosaurs was like extinct? Because at the time, according to geological time, it reached a heat time, and also now we are going to like global climate change, global warming, and I saw like, well, our Earth will come to the same. We proud about the statement. Let me remember about the geological. Our present is represent our past. I mean, I forgot. I already paraphrased. So what happened today is a representative or representative in the past, and in the past will repeat again in the future. So I expected the heat, the temperature will come to reach. I mean, to the point. But why we need mineral again? I mean, we need transition. We need mineral. It means like I'm come from Sulawesi. I talked with Maria here. I forgot, sorry, your family name. And we are Indonesia. We have our island. The island is polluted because of the critical mineral that you mentioned. And from Igor's slide about the problem will be biodiversity, our environment, our ocean, our sea. Why? I mean, okay, oil and gas, it's enough. Why we need mineral transition? I mean, critical mineral. Well, our Earth. I don't want to say like pessimist, but realistic, because well, I know if we say about economic energy demand, why energy demand? Because population increase, but why not produce somehow in advanced technology for fossil fuels? Because people, government, they take all the nature of, for example, in my country, I'm from like small island in order to get mining, nickel mining, and then I'm very, I mean, I'm dilemma because in one hand, okay, I'm from management, we should help our company, but at the same time, how about our people? That's the thing. Thank you.
Okay, thank you very much. Other questions and comments? Okay.
Maybe some comments. Hi, everyone. My name is Maria. I'm actually the representative for the critical minerals industry here in Russia. So I'm working for Norilsk Nickel and dealing with strategic management issues. So basically, maybe because I'm a little bit biased and in whatever I'm doing, I should have a clear goal. it's not a critics, but it's just my advice for maybe people in academia how to make the research more practical for what companies do. Currently, being in the critical minerals industry as a company dealing with strategic issues, we do need to take long-term stakes. In order to do this, we need to think, as usual, about growth, about margins, and about risk mitigation. For this sake, we speak a lot about critical minerals. There are so many research papers, but then we come to basic issues. What's going to be the quantitative demand? What's going to be the demand and supply disbalance? We can't get any, not only like reliable information, but at least some scenarios of what the imbalance can be in terms of each mineral, and it's important for our strategic management. Second, then, everyone is speaking about critical minerals. I don't think that we can use broader research such as whatever US Geological Survey can offer us, just because it's some average, and we are in this particular country, so we can't allow ourselves to deal with certain averages. We basically need to see what we do have here in Russia in terms of geological resource base, what's going to be the geographic areas of driven by geopolitics, by the areas of our interest where we want to be present, and what's going to be those technologies that's going to drive the long-term growth and quantitatively assessed demand for critical minerals. And secondly, since a lot is driven not only by technologies, which are developing rapidly and unpredictably and disruptively, and since a lot is now driven by geopolitics, which is not possible to be assessed, at least by companies, we do need closer contact with governments. And in this case, I guess that academia can help us by actually stressing this issue of necessity to cooperate, and maybe offering some concrete areas in which we can cooperate, driven by best case examples, which you see globally. I did my own research into critical minerals, Russia related. I had to look into critical minerals lists of different key regions which are driving global economic growth, such as China, EU, Russia, and US. And on a comparative basis, my feeling is that Russian critical mineral list should be updated. It does not reflect the current technological paradigm. And I guess this is something which academia should deal with too, and give some recommendation to state regulators so that this work can be completed and in a possibly short time. That's my advice. Thank you.
Thank you very much. We can maybe take one more and then we proceed to responses. One more? Somebody? If not, I suppose we can give the floor to our speakers and then a discussion to respond. Would like to be first? Okay.
Yeah, I can start. I would like to start with the first question. And first question is related with Europe, and in Europe, and specifically production is there is no more production in the critical minerals. And so, of course, in my papers, and I chose for the OECD countries, of course, mostly in the Europe countries. For these countries, import the critical minerals from the other countries. And so, yes, they have the technology. They are the developed countries, most of the Europe countries, but unfortunately, production is there is no production. And also, Igor is we can see for the places, production and processing places, and in the Europe countries, maybe very less country maybe produce of the critical minerals. So unfortunately, it is not possible. for them, and so they have to import for the critical minerals from the other countries. And specifically, yeah, China, US, Canada, Australia, and also some of the African countries has a big potential of the critical minerals. For the second question is related with the environment. Yes, actually, of course, just only we are looking for the demand and supply perspectives, but for the extract of the critical minerals directly impacts of the environment. This is the big issue. And also for some of the African countries, they can say that, yes, okay, developed countries going there and they can extract of the critical minerals, but they don't consider for the environment of the, that country. Actually, of course, for this, yeah, some of the researchers just only focus for that area, but in my papers, I am ignore, and because just only I would like to look at from the supply and demand perspectives, because in my papers I am using for the econometric analysis, and but this is the main issue. For the third questions related with China, actually, of course, maybe you can say that, and so, yeah, China, there is many critical minerals located there, and also they can processing as well, and but you can say that, and China is not able to produce of the high technology. No, at the present, China is the big rivals for the US, and they can produce the very good technologies related with the renewable energy technologies, and so of course they need the critical minerals. In the GCC countries at the present, I am in Oman and I am working in the GCC countries as well, and of course they focus on the renewable energy technologies, renewable energy sources, and hydrogen energy, hydrogen, solar, and PV. Actually, of course, they are not produce of the technology. They have to import. They have to import the technology from the other countries. When they can compare of these technologies, China, US, or Europe, okay, Germany, and of course China provide the technology more cheaper than the other countries, and so they can prefer the China. And also, as when we compare as a quality, yeah, actually, of course, acceptable quality for the China or South Korea. And so for the maybe for the past years, we can talk about the China. Maybe they can produce of the product with the low quality, but at the present, no, they are working so much, and so they can produce the high level, cutting edge of the technology, and they are selling the entire of the world as a cheap. And also your question, I don't understand your question. Just only you make the comments related in your country. And yes, Indonesia is a very small country, but maybe pollution. And but yes, nickel is the located there. They can extract of the nickel, and also you would like to mention why they can extract for the critical minerals, because of course we have to look at in a general, because also the definition of the economics, okay, we are starting with the scarcity and choices, and for the scarcity directly reflects of the resources. Actually, for the resources it is the limited, and so maybe they are using for the coal and for the other fossil base of the resources, but we know that this resources is the scarcity, and so of course they have to skip for the clean energy, clean energy sources. For the clean energy sources, wind, solar, they are the free and they are the unlimited, and so for the pollution, but they have to skip for the clean energy technologies, to stay in the just only consider for the fossil base of the sources. Not acceptable, not logical at the present. Of course, most of countries have a problem related with the environment, and also this is another issue. Extract of the mineral resources directly impact of the environment. But of course, when we have to consider as a separate, and also which one is the best option, and second word in the economic choices, and we have to choose that one. Okay, maybe Igor, you would like to add something.
Yeah, thank you very much for so many interesting questions. I will try to answer them very quickly. Svetlana's question about the assessment of like the reserves and deposits in Europe. I don't think that in Europe the problem is the lack of reserves and deposits. Yes, you're right that many critical metals and minerals, they are more or less everywhere. And there are such assessments, of course, like US Geological Survey, they make assessment of reserves of different, I'm not sure about all the critical metals and minerals, but for many of them, for sure, they make such estimates. But the problem is that that is not that they don't have reserves, but the problem is that they can't organize production because of the many different issues, starting from environmental issues and finishing with the bureaucracy. The same story is with the United States, where only this year, I think the first mine of critical metals and minerals was opened for the last 10 or 15 years or something like that, because they could not organize the opening of these mines because there should be a lot of allowances, because these are very risky projects in the context of environmental impacts, in the context of the property of land, to whom land belongs, and there are many issues related to the indigenous people and indigenous community in US, for example. And the same thing is in Europe. Look at the debates about the lithium reserves in Serbia. So the European Union wants very much to start to launch the lithium production in Serbia. No success so far. Even in Serbia, though, the environmental demands there are much weaker than somewhere in Germany. But even in Serbia, it is politically unfeasible so far. Probably they will succeed, I don't know, but it is very complicated, and it is not because of the lack or abundance in terms of reserves. It is about different issues. Igor's question about processing. I think that of course, this issue of pollution and environmental impact for processing also matters. But I think the technological issue is not less important in the area of processing, because processing of critical metals and minerals, it is very complicated story. And right now, China is far beyond all the other countries in the world in terms of the development of these technologies. Not for, again, the situation may be different for different critical metals and minerals. There are some conventional critical metals and minerals like copper or aluminum or like nickel even, where other countries are quite successful and there is no such technological problems. But for new critical metals and minerals, China is far beyond everywhere. And it will take, I think, decades for some countries of efforts to somehow catch up here. So I think this also matters. In terms of the dependence in China, of course, there are some local dependencies on imports. Take cobalt. Technically, China is dependent on deliveries of cobalt from Democratic Republic of Congo, but actually these deposits are controlled by China. So maybe we consider that it is a dependency. Probably at some point of time, something may happen in Democratic Republic of Congo with this control and with some change in property, and China will be under risk in this case. There is a dependence on nickel, on processed nickel, on the imports of processed nickel from Indonesia. It is probably one of the few critical metals and minerals where China is not dominant, actually, in terms of processing, not in terms of the deposits. But again, all this nickel processing industry in Indonesia was organized with the participation of Chinese money and related to Chinese demand to a huge extent. So technically, this dependency exists, but in fact, so far, it is not critical, I think. Yeah, in terms of technologies, China is beyond other countries for most of technologies, and not only in terms of their like cost, but also in terms of the number of patents for most of the energy transition technologies. So I think that China here is more or less independent, though of course there may be some nuances for very specific metals or very specific technologies, of course. And the Maria's comment on like environmental impact and other related issues. Yes, to some extent it is very similar to what I tried to show in the related part of my presentation, that on the one hand, we have global environmental problems, and critical metals and minerals are a part of solutions for this problem, global problem. At the same time, there are a lot of local problems or like national problems where critical metals and minerals, in some cases and in many cases, actually, it is the part of the problem rather than a part of solution. And yeah, what can I add here? I do not know this. I think that your purpose here is quite well describes what we have nowadays, but there is a capitalism, there is international capitalism, yeah, and yeah, we as analysts may only like register some of these trends, but we can't fix them. But there are a lot of course, unfairness here, and at different levels. But there is a lot of unfairness in the world, unfortunately. Yeah, and other Maria's questions and comments on different aspects of critical minerals topics. Thanks. First of all, it's very valuable to listen to the feedback from the industry. We worked with Norilsk Nickel actually several years ago exactly on scenarios of demand for different critical metals and minerals in different scenarios of global decarbonization. And there are a lot of different like obstacles for this forecasting, and in general, as Niels Bohr said, that forecasting is always difficult, especially for the future. Yeah, and here especially because what does it mean that the demand will grow or will rise sevenfold, for example, or like threefold by 2030? We have no such capacities to meet this demand so far. This means that if the demand for like copper, for example, increases thrice by a couple of decades, it means that it will change the like prices globally, and it will launch some technological change which makes the global economy less dependent on like copper, for example. And it means that the finally demand would not be would not rise thrice for these decades, but will rise only like twice or even less. And it is very difficult to catch these issues because it is, again, first of all, it is because of it is about technologies and some technological responses to the changes in the prices and the relative prices for different metals and minerals. That's why it's very difficult to make such forecasts, though many agencies try, and we try ourselves, and we try to take it into account, but it's not very easy. And thanks also for this mentioning of critical metals and minerals list for Russia. I fully agree that it should be updated, and I'm glad to hear that there is agreement on this from industry as well.
Just one more comment. I guess if we take the critical minerals outlook, the recent one by IE, we definitely see that will be a deficit of copper after closer to 2035. So we already know this, right? But I'm not sure that the local regulator understands this. And basically, there are all fundamentals supporting this trend. You have the world which is switching from hydrocarbons to electricity. You have AI trend, you have robotics, electronics overall, right? Definitely copper is hard to substitute. So it has unique quality of electric conductivity. So why not, if we are confident that copper is required, copper cannot be substituted, copper is critical. So why we are not, for example, doing something to stress the importance of copper for regulators, so that we have like stimulus for companies to invest in copper, so that maybe we provide companies with more access to geological data, which is now not the case. So I'm not sure how US Geological Survey, for example, collects data on Russia, if Russian data, geological data, is already closed for Russian companies which are in extraction sector. So it's a big issue, I guess. And these issues, maybe they're not quite evident for regulator, but maybe academic. And we, if we will stress these issues, will be considered as a biased. But maybe academia can work here as an intermediary, helping us to solve such important issues, I guess.
Yeah, I agree, and we try to do it, and probably we will try even more intensively. But I fully agree with it that we should stress these potential deficits and bottlenecks, and yeah, probably try to start the process of like coordinated development on such critical sectors.
And in terms of copper, I guess if we want to stress its criticality, we should go beyond green technologies, also looking into electronics, which will make it even more critical, I guess.
Just a couple accents, perhaps, because my colleagues already have answered questions quite exhaustively. On Europe, I'd say sources of competitive advantage are scale of processing, access to low-cost energy, and yes, access to resource. The resource access, not so good. They are starting to experiment with geothermal brines, but it's not like they have abundant lithium deposits anywhere in proximity. They will research some, but unlikely. Access to energy, I think it's discussed well enough. I don't think Europe is going to be the low-cost energy region anytime soon. And access to large-scale processing, well, I guess they, in theory, could do that. In practice, we observe how much resistance domestic projects of that type already meet. And finally, I forgot water. Of course, the water is also needed, and large parts of Europe, amongst them Portugal, where they currently have production of lithium, for example, experiences significant water stress, and it's only going to get worse. From the same perspective from China, much better situation, still dependent upon resource imports from other geographies. One of the questions is for how long other geographies will be content with existing arrangements of exporting their resources. I think chances are not for too long. And whether China is going to be prepared to reinforce their control of that excess, that's a big question, given other geopolitical challenges that they are currently meeting. For the comment on can really the Earth sustain energy transition minerals after it barely survived hydrocarbon revolution, I don't have a good answer, but I just want to note that a number of rare earth minerals can be processed or produced at, for example, conservated coal mines. There are some studies like that in the US, in their coal belt, but I think it also can be researched in other geographies, including Europe. It can also be produced from conservated oil wells, because it's the same geothermal liquid, so to say. So there are small niche solutions where actually producing rare energy transition minerals can be done with lower environmental footprint, and also maybe with some synergies with other restoration projects. And with Maria, I fully agree. I think the understanding of the geology potential in Russia is a huge challenge beyond copper. And certainly there needs to be an updated studies for many minerals, including energy transition ones, but frankly also for oil and gas. So yeah, fully support.
Okay, I have one question to Igor. Actually, in your presentation, you mentioned your paper, and in your paper is the include the 7 years period time. And also, of course, when, yes, you talk about your data. One of your control data is the EPS. Actually, when we look at in your results, and unfortunately, your EPS is not significant with the environmental base of the goods and also for others. And how did you explain this? Because we expect to see this data should be significant, because also most of the papers, and actually I know also I use this data in my papers, always we find for the significant. And so how did you explain for this? This is specific
You
question.
mean that environmental policy stringency, it doesn't affect positively the exports of... it is insignificant. Yeah, it is not for development of low carbon technologies or environmental goods. It is for exports. For example, if you have more environmental, it may be explained. I'm not sure, 100% sure that this explanation is the only one, but one possible explanation is that if you have more environmental policy stringencies, then you should consume more environmental goods and low carbon technologies yourself. You export less to other countries. So it is one of the possible explanations. So if we take not the exports, but like production of these goods, the situation may be a bit different.
There is a lack of to find of the data more than the 7 years, and actually this is another issue. Actually, of course, you apply for the panel data analysis, and for the panel data analysis, basically, at least we have to get the 10 years at least. This is at least based on the number of the all countries, and so you maybe because this is the reason you find the insignificance, because 7 years is a bit less. Yeah.
On the one hand, I agree with you, but on the other hand, I should say that 10 years ago, it is actually not 10 years ago, but if we take, for example, 2014, 2023, the last available years for 2023, in 2014, we had absolutely different landscape of exports of environmental goods and absolutely other landscape of critical metals and minerals trades. So for the last 7 years, it is the period of very extensive energy transition globally. And so if we go further to the past, there may be question of how comparable this time is for the current period. But thanks for this comment. We will think how to probably cover the broader time series. But I think that 7 years for so many countries, for like 35 countries, for 34 countries. So in general, it is enough. The number of observations is more or less enough.
So with that, the possible future directions of the studies and also the dialogue about the possible cooperation amongst us, the researchers, the private sector, and other organizations, I think we can conclude today's seminar. I would like to thank very much all those who came here and been here in the room today with us, and all those who connected online. I hope this is a first take on the hot issue, and we will continue this in the future in different senses in terms of the seminars, but also possibly with JET projects, some of you. Thank you very much, and have a good day.